In part A, we need to calculate the thrust that is provided by the airplane's propellers. And the airplane's propellers have to pull a couple of different objects. They have to pull this giant airplane, but they also have to pull the glider as well. So what we're going to do is treat the pair of objects as a single system of analysis. So we can go ahead then and draw the free body diagram showing the forces that are acting on that system. Now, of course, we have the downward gravitational force. We can symbolize that by mass total multiplied by g. We're saying mass total because we would have to add the masses of the airplane and the glider. And then we have the ground pushing up on that system. This is known as the normal force. And then, of course, we have the propeller, which is providing this thrust force. We're just going to call that T for thrust. And that is the force that we are actually trying to compute here. Now, how do we do that? Well, we could apply Newton's second law in the x direction. And this simply tells us that the sum of the forces that are acting in the x direction is equal to the mass of our system multiplied by the acceleration of our system. Now, the mass of our system is very easy to calculate. All we have to do is add the mass of the glider and the mass of the airplane. And then, of course, the acceleration of this system is given to us as well. It's 2.2 meters per second squared to the right. So let's go ahead and plug those values into our Newton's second law equation. Good. And then the only force that's acting in the x direction was the force that we called the thrust provided by the propeller. So we're just going to plug in T, and then we can easily calculate this by simplifying the right-hand side. And when we do that, we get 4897 approximately. And since we're multiplying kilograms by acceleration, we end up with newtons. Now, your homework system might want you to convert that into kilonewtons. And we can use the following simple conversion factor. Hopefully, we all know that 1 kilonewton is equal to 1,000 newtons. And by multiplying by this conversion factor, we can see that the newtons here are going to cancel out. And when we simplify this, we end up with a thrust force of approximately 4.897, and then this would be in kilonewtons. So this would be the correct answer to part A. Let's go ahead and look at part B. Part B asks us to calculate the magnitude of the tension in the cable connecting the airplane and glider. Now, if we look at the picture, the tension in that cable would be this force that's pulling the glider along to the right. So in this case, what we're going to do is just analyze the glider as our system. So we can come down here and we can set up another free body diagram, this time showing just forces acting on the glider. We have the tension, and we're just going to call this T prime so that we don't confuse it with the thrust. And that would be the only force acting on the glider in the x direction. And so we can actually apply Newton's second law again. The sum of the forces in the x direction is equal to the mass times the acceleration. Now just be a little careful here, because for the mass, you're only going to be using the mass of the glider because that's our current system right now. Let's recall that the mass of the glider was the 276 kilograms. So we're going to plug that in. There we go. Whoops, we're having a little glitch here on my screen. There we go. So we're going to take 276 kilograms, and then the acceleration, again, of this glider was 2.2 meters per second squared. The only force acting in the x direction is that tension. So let's go ahead and pick up our calculators and compute the right-hand side. And when we do that, we can see that the tension pulling the glider along is approximately 607 newtons. And this would be the correct answer to part B. Thanks for taking the time to watch the video. If you're interested in making a small donation to my cause, I would greatly appreciate it, but please do not feel obligated to do so. I appreciate you taking the time regardless to watch.